Okay, I'm going to prove if A divides A plus B and B divides A plus B, then the least common multiple of A and B divides A plus B. Okay, so first, let's create some variables. So I'll say L equals LCM of AB and S equals A plus B. Next, we will rewrite this. So we want to prove L divides S. So we want to show for some S, there exists a Q times L. Such a Q is in the set of integers. Um, so what we would want to do next is we'll use the division algorithm. So we'll use the division algorithm. We'll divide uh, S. We'll divide S by L. So S equals uh, G. We'll just use G. The sum is equal to G times L plus R, where R is between 0 and L. Okay, so then the next step, we know A divides A plus B. Thus, A divides B by the divisibility of integer combinations. So A divides B and B divides A. Those are both true. Okay, so then S equals G times L plus R. We can rearrange the sides, so S minus GL equals R. And then what is S? So S equals A divides S and B divides S. So that's also what we have. And also, it is true that A divides L A divides the least common multiple because of A and B, because by definition A is a multiple of the least common multiple of A and B. So A divides L, and B divides L. Thus, we'll rewrite these. So A we now have A divides or S is equal to, we'll just say G1 times A, and S is equal to G2 times B, and then we'll also say L is equal to G3 times A, and L is equal to G4 times A for some G 1, 2, 3, 4 in the set of integers by the definition of divisibility. So the next thing we'll do is we can substitute this. So we'll first do A. So S is equal to G1 times A minus G. L is equal to G3. G3 times A. And then this is equal to R. Thus, A divides R because we can factor out A from both sides. So now we have A divides R. And equivalently, we can do the same thing and we'll get B also divides R. Okay, so what does this mean? Because R must be less than L, and L is, I'll just say because R is less than the least common multiple, we shouldn't be able to have anything that divides smaller than least common multiple, or else it would not be the least common multiple. Because if there's something that is greater than 0, and A divides that number, and B divides that number, then that would be the least common multiple. Thus, R must be 0. R is equal to 0. So, from this, we now get S is equal to G times L for some integer. S is equal to G times L for some integer G in the set of integer. And so now, because of this, we get L divides S. Thus, the LCM of AB divides A plus B, which is the sum. And that's our proof.